Good morning everyone, my name is Felipe Gil Bernal, a student of the Master's degree in Earth Science at the Universidad Nacional Autónoma de Mexico, and today I will show you this presentation titled The Eagle Ford Formation in Northeast Mexico, Facies and Gamma Ray Correlation. Okay, let's go. The Cenomanian-Turonian sediments of Sabinas Basin in Coahuila, northeastern Mexico, correspond to a rich succession of black moonstones, gray and dark limestones, and thin layers of bentonite. In general, these sediments compound principally the Eagle Ford Formation, a unit that has been studied in detail in southern Texas, USA, whereby exists a lot of sedimentological, petrophysical, and petrographic information of these sediments in Texas and the basin related with Cretaceous Western Interior Seaway. However, in Mexico, the study of this unit and the basin related to the southern part of the Cretaceous Western Interior Seaway, or Interior Mexican Sea, remains in an early stage of development. For this reason, to determine the paleoenvironmental and paleoclimatic conditions in northeastern Mexico during the Cenomanian-Turonian interval, this investigation focuses on the sedimentological, petrophysical, and petrographic analysis of the IR1 and IR2 cores drilled in the periphery and the center of the Sabinas Basin, respectively. In Mexico, Sabinas Basin represents the extension of the Cretaceous Western Interior Seaway in the south. This basin extends from the central part of Coahuila State to the west part of Nuevo León State, covering an area of 37,000 square kilometers. The petrophysical and sedimentological analysis of the IR1 and IR2 cores allow us to establish that these Cenomanian-Turonian sediments correspond to the Buda and Lower and Upper Eagle Ford formations. The petrophysical analysis made with a handle spectrometer shows the uranium and the SGR records, which mark an abrupt increase between Buda and Lower Eagle Ford contact, and a gradual decline from Lower to Upper Eagle Ford formation. And if that was not enough, the records show few changes in the Eagle Ford formation, which could be correlated with some members reported in the American basins, such as the Middle Shale member in Lower Eagle Ford and the Lantry member in Upper Eagle Ford. But why is this important? These petrophysical results are important because there are very few reports about gamma ray analysis made on cores with a handheld spectrometer. In addition, the petrophysical correlation between the cores in Sabinas Basin and other cores and outcrops in Texas, such as Yona 1 and Los Sierra Canyon, demonstrates the lateral extension in the southern USA and northeastern Mexico of the mentioned units, especially Eagle Ford. And how do we know that the signals are correct and could be correlated with those reported in South Texas? Well, first of all, it's easy to see a great similarity between our results and those reported in some basins from South Texas. Besides, we made geochemical analysis through ICP-MS to identify the content of major and trace elements. With this data, it was possible to obtain the SGR record using the values of potassium, uranium, and thorium. This data processing gave us a curve very similar to the one obtained using the handheld spectrometer. Otherwise, it was possible to identify 7 lithofacies in the Eagle Ford formation during the sedimentological analysis. These lithofacies are based on those described by Minicini et al. 2018. The lithofacies described in this research are: Facies G consists of a homoky cross-laminated dark limestone with some deformation structures such as low class and thin sedimentary folds. Facies H is a poorly laminated granite limestone with a very high degree of recrystallization and a high content of fish bones. Facies C consists of a planar laminated dark mudstone with a low content of thin clear layers. Facies E is composed of a planar laminated rippled dark mudstone with a higher content of thin clear layers than Facies C. Facies GL is present as little imbricated bioclastic association scattered in the entire Eagle Ford formation. Facies J represents a borrowed fish-bearing clear limestone with a high perturbation index, and Facies TUV corresponds to layers of greenish bentonite. During the petrographic analysis, some characteristics of the lithofacies described previously could be determined in thin sections. For example, it was possible to recognize a recrystallized limestone with a high content of fish bones, facies age, thin layers in mudstone compound by plantiforaminifera, facies C and E, imbricated bioclast or inoceramic assemblage, facies GL, clear limestone with a high content of boron, facies J, and thin layers compounded by opaque minerals and quartz and plagioclase crystals, facies TUV. Nevertheless, we prefer to use another criterion to establish the representative microfacies. This criterion is based on the grain abundance plots, and we could establish 3 representative microfacies. Paxton, Wakestone, or calcisphere rovea crinids and Benthiphoraminifera related to Buddha formation. Wakestone of Plantiforaminifera and filaments related to Lower Eagle Fold formation, and Wakestone Paxton of Planti and Benthiphoraminifera, bivalves and brachiopods, facies related to Upper Eagle Fold formation. In some intervals, it was possible to identify a 4 representative microfacies, a Paxton of imbricated bioclast, principally inoceramics, but this microfacies is common in Eagle Fold formation, and it's not related to a specific lithology or interval. The first representative microfacies is related to the Buddha limestone, which does not have lithofacies established in this research. Wakestone of Plantiforaminifera is related to the lithofacies C and E, and Wakestone Paxton of Foraminifera, bivalves and brachiopods is related to lithofacies J. The lithofacies TUV is recognizable in thin sections, but it's very thin, and we group it with the established microfacies. In summary, we have 3 units contained and will describe in the Higher 1 and Higher 2 cohorts, Buddha and Lower and Upper Eagle Fold formations. The Buddha formation consists of a lithofacies compounds by a borough clear and sandy limestone, with a low value in uranium and SGO records, and a microfacies of Paxton Wakestone of calciospheres, rovea crinids, and Benthiphoraminifera. The Lower Eagle Fold formation has the highest values of uranium and SGO records, and is compounded by lithofacies C and E, which are related with microfacies of Wakestone of Plantiforaminifera and filaments. Finally, in the Upper Eagle Fold formation, there are slightly lower values of uranium and SGO records related to Lower Eagle Fold, and it is compounded by lithofacies J. This lithofacies corresponds to microfacies of Wakestone Paxton of Planti and Benthiphoraminifera, bivalves and brachiopods. Well, what do you think about all this information? Is it easy or not easy? Really easy, yes. Everything in geology is very easy. But okay, we had a lot of data and a pretty good description of the units mentioned previously. Then, what happened during the Cenomanian-Turonian interval in Safinez Basin? First of all, during the deposition of the Buddha formation, we found the lowest values related to uranium-thorium, a relation found through handheld spectrometer and ICP-NS results. These low values indicate deposition in an anoxic environment. For this reason, it's common to see Benthiphoraminifera and very high index butyration in the Buddha formation. But the presence of calciospheres, rovea crinids, and radiolarians demonstrate that the basin had a high nutrient content in the surface waters, and during some periods it could present disoxic or anoxic conditions. In the Lower Eagle Fold formation, we had a few facts very interesting. First of all, it could be separated in 2 different members in both cores. In the lowest member exists an increase in the value of uranium-thorium relation and the abundance of radiolarians, bivalves, and Plantiforaminifera. These features indicate anoxic conditions that were accompanied by high primary productivity on the sea surface, and for this reason we could identify a great content of thin clear layers compounded by the accumulation of Plantiforaminifera. In addition, the uranium-thorium relation shows 2 peaks in the lower member, which indicate the most anoxic conditions present in Eagle Fold formation. In general, the lower Eagle 4 formation has features related to a deposition in a disoxy and oxy environment. In the uppermost member of the lower Eagle 4 formation, we can recognize two peaks in the uranium content and the content of bivalves. These peaks can be correlated with another disoxy and oxy event, but with a minor impact on the deposition processes in the basin. Finally, in the upper Eagle 4 formation, we can identify two members, the lower and long tree. In general, this unit shows a decrease in the abundance of Plantiforaminifera and the uranium content, and an increase in the abundance of Ventiforaminifera, which indicates oxy conditions in the basin during the deposition of these units. The lower member shows two peaks in the SGR record and the content of Plantiforaminifera, Radiolarians, bivalves, and brachiopods, indicating very short periods of environmental stress, high primary productivity, and oxygen poor conditions. Otherwise, we found the most oxygen conditions of Eagle 4 formation in the long tree member of upper Eagle 4 formation. This member has more Ventiforaminifera and the lowest content of filaments and a very low uranium-thorium value. However, there is a peak in the abundance of filaments, uranium content, and the uranium-thorium relation, indicating a new short period of oxygen-poor conditions. Well, we can conclude that the environmental conditions in the Sabinas Basin during the deposition of the Buddha formation were principally oxygenated with a high nutrient content. Then, the lower Eagle 4 formation was deposited in a disoxy and oxy environment, and in at least 4 intervals, the conditions were more stressful. However, there are 1 or 2 intervals when the conditions were more oxygenated. Finally, the upper Eagle 4 formation was deposited in an oxy environment without any environmental stress, except for a very short period when the conditions could be more disoxy or anoxic. Then, from the spaces of Sabinas Basin in northeastern Mexico and the sedimentological, petrophysical, and petrographic analysis of IR1 and IR2 cores, my name is Felipe Gil Bernal. Thank you very much for your attention and have a happy rest of the day.